Hi, this is Coach Johnson coming to you. This is the second installment of the Macromolecules. It'll be the last installment before we go on to sales. I want to say hi out there to everyone. I know these are strange times. I just want you to take a look at a timeline. A lot of times I show you what's going on the calendar. Yesterday, our governor basically kind of extended our stay-at-home kind of deal that we're having to undergo, as far as social distancing and whatnot. So, as far as schools go, that kind of extends our period that we know we're out. It basically extends it. I think he mentioned Monday, April 6th. Well, we're on spring break there, so the earliest we would even attempt to come back would probably be the 13th, which that there's a lot that needs to go on and whatnot before then. If we are probably gonna meet that date as far as coming back, which we would be coming back from spring break. But anyway, just want to let you know, I appreciate you handing in your stuff from the Macromolecules segment. As I said, I'm not the most tech savvy person in the world. So I appreciate y'all working with me by sending in Google Docs, either taking pics and emailing me or sending them on Remind. Just get them in any way you can. Now keep in mind, some good can come out of this based on, you as a student. Some of y'all will probably be taking online courses down the road, maybe in college or whatnot. And certainly this is great preparation for that. Me personally, I'd rather be in class teaching. It's easier for me. I like the correspondence and whatnot, but it has probably opened my eyes to online education and what needs to take place in order to successfully do that. Keep in mind, you had to be self-disciplined in you getting your stuff in. This is a great learning lesson as far as self-discipline and also talking about evolution, which we do a lot of times, and survival of the fittest. Those that do this, knowledge is power, and those who do this will have an advantage over those who do not do it. As far as how much knowledge you gain. This could down the road. Everything's a competition, and the more you learn, the more you prepare yourself, the better prepared you'll be in whatever facet of life, career, occupation, or whatnot you choose to do. And that's what this does right here. This is teaching us, we got to be self-disciplined. We got to, get our work done amidst all the, the chaos and the strangeness that this is bringing. I think we got 7 confirmed cases in Georgia. Now, in Lawrence County, as far as the coronavirus, Georgia just went over 1,000 cases overall. This is Tuesday, March 24th. It's not as bad as in New York. New York, basically, they have coronavirus patients in the hospitals. The governor's saying. And he's saying that they don't have enough respirators because coronavirus, one thing it does is it jeopardizes basically your respiratory system's capacity to consume oxygen and use oxygen for the body. And a lot of coronavirus victims, patients who are in bad condition, need to be put on a respirator. Well, for every 4 coronavirus patients that they need to be on a respirator, they only have 1 respirator currently available. So, it's a lot worse in other areas. Those harder hit areas where the population is more dense, like, California and New York are experiencing those issues. Now, I want to, kind of go on to the topic of macromolecules. We need to finish it by tomorrow and get on with sales. Now, the good news is our governor has also, put a halt on testing for the year. So no milestone, for us to prepare for the end of the year. But we also have these standards to cover before we get done with the biology course that I'd like to get covered. We got cells, we got cell division, we got photosynthesis and cellular respiration, we got genetics, we got DNA to cover, all before hopefully your time in biology is done. But like I say, we can do it with the satisfaction of knowing that we really don't have a milestone hanging over our heads at the end. But we do need to get the information covered to make you more prepared, for what comes down the road. It may be a AP biology class you choose to be in as a senior. It may be, a biology class, you had to take in college or whatever. An anatomy class you take as a senior, it still has some fundamental biology concepts to it that, if you learn them, with me here in the rest of this course, it'll bode well for you in the future. Okay, going to macromolecules, finishing up. There will be a quiz I'll put online tomorrow morning. I'll set a deadline, I guess, for 11:59 tomorrow night. It'll be a short quiz. You can simply put those answers, multiple choice answers, to those on the Google Docs, send it back to me. There's really a multitude of ways you can send it back. Put it on a piece of paper, take a picture of it, send it to me via reminder email. I'll get it. Okay, so no excuses for not getting this done. I just want to take a quick review. It will be over macromolecules, carbohydrates, lipids, proteins, nucleic acids. Okay, now want to start off first of all going back. This is from the Wolf book, talking about these molecules of carbohydrates, macromolecules, lipids, proteins, nucleic acids. Remember, we looked at this in the Wolf book. It had color codes of these molecules, and remember our 6 major elements that make up living things. They are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Well, if you recall, carbohydrates have 3 of them. They have the carbon, which is the charcoal color here, the hydrogen, which is the yellow, and the oxygen, which is red. Usually remember in a formula like C6H12O6, that 1 to 2 to 1 ratio we were talking about. Okay, lipids, have the same 3 elements, carbon, hydrogen, oxygen, but in a different ratio. Remember, it's got a lot more carbon, the black, and the hydrogen, the yellow, than it does the oxygen. And if you remember, our most common formula there was C57H110O6. Okay, proteins that we had discussed before we started, before we got out, for this extended period, had the element, had carbon, the black, hydrogen, the yellow, oxygen, the red, but added in the blue, which is nitrogen. So carbon, hydrogen, oxygen, and the big one, nitrogen. Now, some amino acids, which are the building blocks of proteins, have sulfur as well, but notice sulfur not mentioned on here. Okay, so that's those, and then the one that we have left is nucleic acids. Now, if you recall, nucleic acids, your carbon, which is your charcoal, your hydrogen, which is your yellow, your oxygen, which is your red. So they have carbon, hydrogen, oxygen. Now, one of your questions on the preparing for the EOC was what makes up a nucleotide, which is the building blocks of these nucleic acids. And obviously, the 3 things that make up them are a sugar. And remember, sugars are made up of carbon, hydrogen, and oxygen. They're also made of nitrogen bases, which you see in blue. Which, if we take a look here, this kind of deal right here. The shape of DNA is what we call a spiral helix or twisted ladder. Okay. Now, it's what we call a double helix. But if we take a look at it right here, it basically takes that shape, And the nitrogen bases, which are in blue here, are basically the steps of the ladder. Okay? Those are the steps of the ladder that are formed right there. And that's your nitrogen. And then you add in a green color right here, which is your phosphorus. So, nucleic acids have 5 of the 6 major elements found in living things: carbon, hydrogen, oxygen, nitrogen, and phosphorus. Now, the reason phosphorus is, one of the big 6, so to speak, is basically because of DNA. Everything has DNA, so phosphorus makes up DNA, so everything has to have the element phosphorus, okay? Because all living things have genetic information, okay? All right. Now, I want to go over the questions from that you had to hand in, and just want to take a look at them right here. Going over these, make sure you understand them. Some people, when you first, those who handed in their stuff, turn it in a little, early, I was able to correct theirs, any errors, and kind of give you immediate, personal feedback. But I'm just going to take a look at it now. Okay, so we take a look here. This is just a simple one right here about sugar and sand form a mixture. That's kind of a physical science one as opposed to biology. But we start with biology on 6. Remember, these are big molecules called polymers. I kept referring to this right here, as a big molecule of polymer made from smaller units right here called monomers. Okay? Well, you can't make polymers really out of polymers. So in order to make polymers, you join together smaller units called monomers. Okay? Number 7, it says, which formula represents an amino acid? Now, this was missed by a few of you right here. I don't know, it was maybe because of a couple of reasons. Number 1, sometimes this, multiple choice, the way it's organized kind of confuses you. Like, the A right here refers to that one, the B refers to that one, the C there, and the D there, of course. But the reason the answer was C, because it contained the element nitrogen. And remember, nitrogen is a key component of proteins, and amino acids are the building blocks of proteins. Okay? Now, going to these questions right here, there's that question again. Proteins are polymers formed from amino acids, building blocks of proteins. Number 9 talks about, number 9 and 10 actually talk about enzymes. Okay, an enzyme speeds up a reaction by lowering the activation energy, so the answer is A. Number 10, in a chemical reaction, a reactant binds to an enzyme at a region known as the active site. That was discussed in my previous lecture. Okay. Those were missed by a few of you as well. Now, let's go to this. This was preparing for the EOC, or what is now called our milestone. Number 1, it says, which of the following is a substance that lowers a chemical's reaction's activation energy? Well, remember, we learned it was an enzyme. But enzymes are types of these, which are catalysts, B. Okay? Now, which one of the following is not an organic molecule in living things? Of course, that'd be sodium chloride, because proteins, nucleic acids, carbohydrates, and the missing one, lipids, are. Number 3, which combination of biological molecule and function is correct? Here's where you use the process of elimination. On B, it says lipids store genetic information. No, they don't. Nucleic acids store genetic information, so that can't be right. Carbohydrates form membranes. Remember, lipid bilayers make up cell membranes. So that one's not right. Nucleic acids catalyze reactions. Because catalyzed reactions refer to enzymes, and enzymes are proteins. So no. Okay? But we do say proteins regulate cell processes because that's what, certain ones do, particularly with enzymes. Okay? Enzymes help speed up chemical reactions that would regulate cell processes. Okay? Number 4, in what ways are carbs and proteins similar? Here's again where you use the process of elimination. It can't be B because both don't contain nitrogen. Carbohydrates don't contain nitrogen. Both store genetic information. No, because that's nucleic acids. Both include sugars and starches. No, sugars and starches are carbs only. So the correct answer, be due to the process of elimination, would be A, both used in biological structures. Now, here's where that's the case, because we got certain proteins that are located within the cell membrane that basically serve as pathways that let things into and out of the cell. We'll talk about those with the cell, okay? And carbohydrates like cellulose, if you remember, a complex carbohydrate called cellulose helps give plants, particularly their cell walls, more structure because they don't have bones like we do as a skeleton. So they need structure, and cellulose provides that. Number 5, which of the following molecules is made up of glycerol and fatty acid? Well, fatty should have given it away. That's lipid C. Okay? Now, we go here to number 6. There's the question I was telling you about nucleotides and what they're made of. Okay? Well, they're made of a phosphate, which is the phosphorus, a nitrogen, and the other would be a 5-carbon sugar because that gives you your carbon, hydrogen, and oxygen. Okay? Now, we'll take a look here. This is simple reading a graph. On this graph right here, we have, again, like I was saying, the x-axis and the y-axis. The x-axis is a concentration of catalase, catalase being an enzyme. How do you know that? Because it ends in ASE. Okay? This is the rate of the reaction going this way in the y-axis. And basically, if you take a look, anytime you got, a graph that goes up kind of steadily, what we call a linear graph here, the answer would be C. Reaction rate increases with increasing enzyme concentration. So as this concentration got higher, the reaction rate increased. Okay. Number 8, which concentration of catalase will produce the fastest reaction rate? Well, if we take a look here, the highest one would be 20 right here. 20 not an answer. So you go to the next highest number that's available, and the answer is 15. 15 is higher than 10, higher than 5, and certainly higher than 0. So that's how you read those graphs. Got to be able to be a graph reader to answer these questions on these standardized questions from things like the milestones and SAT and ACT and things like that. But anyway, that's the information on macromolecules. Just want to go back to this. Some people may have a question on this. There's the enzyme. There's the substrate that combines with the enzyme. The location where it takes place is called the active site. When it combines with enzyme and substrate, you have the enzyme-substrate complex, and it produces these products. And remember, catalysts speed up chemical reactions without undergoing change themselves. So the enzyme is unchanged in the process. Okay? And remember, right here, we got basically the same thing we had. Right here, remember I used the colors the other day. How do enzymes work? Well, they speed up a chemical reaction without undergoing change themselves. This is the course of the reaction with the enzyme. This is the course of the reaction without the enzyme. So the enzyme just makes it easier. That's what it does. It makes the reaction easier. I may come back over with something else involving enzymes right before we get into cells, but nothing that you need for the test or anything, or for the quiz, not a test on this. Okay? Quick review right here. Just real quick, remember, all of these right here, macromolecules, big molecules made from smaller subunits, they all have specific functions. Carbs and lipids, their primary function right here is energy. Okay? Proteins, build and repair body parts, is their primary function. Enzymes are types of proteins that have special jobs. Nucleic acids, main job is to transmit genetic information. Okay? Now, let's see. If you know that, you're pretty good for the quiz. You'll be able to, you use your resources anyway. On the On the next topic, which is the sale, I just mentioned, tomorrow we'll spend time finishing the quiz. On Thursday we'll start the sale. We got to kind of start speeding things up a little bit here. To hopefully get the sale done maybe before what would be our spring break. Don't forget, I will put these things, in our classroom, but also I'll also have some hard copies available underneath the pavilion at our tennis courts. Now, we got some rain last night and these things got wet. I'll try to, put them up each night, in case we do get a rain, but feel free to stop by anytime and pick up, a new packet on the sale starting on Thursday. Hope everybody's doing okay. If you got any questions, feel free to, chime in, send me a post at Google Classroom on Remind or an email. Take care and, good luck on the quiz.